I have already sent you the slides. Professor Sharma?
Yes, sir.
I have sent you the
yes.
First lot of slides. So,
Okay.
if you can request your coordinator to put that first slide immediately after this discussion is over, then subsequently I will take it forward or whatever way we can. I think the link is quite good. We can get your man to operate that. That should be all right for me.
Oh, okay, sir. We will try. I will just share that slide and then we'll see.
Yeah.
Okay.
You can speak something, Professor Sharma. Let me see if I can hear you on my earphones.
Yes, sir. I am downloading your slides and then we will put.
You can say
Are you
hello?
waiting? Yeah, yes, sir. Hello. Are you waiting?
Not able to hear you. Hello?
Hello, hello.
You can hear me now?
Yes, yes, sir.
Yes. On the earphone, I'm having some problem. I'm not able to hear you, sir, that well. So I will.
So otherwise it is good. No problem. Voice is clear.
Okay, okay. Voice is quite good. Video is also quite good. And the clarity is also good. So how old is your
downloading your slide?
Yeah, you're uploading my slide. Very good. Fine. So nice of you.
Yeah,
Thank you.
Just a minute. Yeah. Just a minute. So meanwhile, I start the session and then after that we can upload the slides and then you can continue, sir. Sir, your mic is mute. Yes. Good morning to all joining this webinar on software-defined radios and context-aware system. First of all, I would like to thank our Honorable Vice Chancellor Professor Sunil Kumar, and Tech Coordinator, Professor S.C. Professor, Director UIT, Professor R.S. Rajput sir, HOD Electronics, for giving the permission to conduct and organize this 5 days webinar. I welcome our expert for this 5 days webinar, Professor Venkatapati Prithviraj.
Very good morning, sir.
He is, very good morning. Instead of professor, I will call him a senior professor. So he is very senior to all of us. So I take this opportunity to introduce you about the speaker or the expert for this 5 days webinar. Professor Prithviraj has completed his BTech long back. I think most of us did not born itself. So 72 he has completed the BTech, and then he has done the specialized postgraduate diploma in space science and satellite application. That was sponsored from the ISRO Government of India. Then Professor completed his MS from IIT Madras, then PhD from IIT Kharagpur, and then he has put 3 decades in teaching and 12 years of his R&D experience with 2 IITs. He was retired as a principal from the Pondicherry Engineering College, or we can say the Government Engineering College, Pondicherry. Sir has also served as Dean, School of Engineering at Pondicherry University. He was also served as the Director of Information Technology, Government of Pondicherry. Sir has filed 2 patents. One is in the field of cognitive radios, and other one is the quadcopter application for monitoring EM radiations. Sir has guided many PhD scholars, PhD students, published more than, you can say, 150 research papers with more than 200 Google citations. Sir is recipient of Best Paper Award from Broadcasting Society of India. Sir has also served as an expert member with AICT and NBA team. Sir has also served as expert member for monitoring Indo-French international project in the field of information technology. Sir has also received Lifetime Achievement Award from IST Tamil Nadu. And in 2018, he has been appointed as an expert member to monitor the Smart City project by Government of Pondicherry. So it is not brief, it is long, what you could say, the feathers put into the ground. So it is long description. So I stop here itself, and our Vice Chancellor and Tech Coordinator, they are having some meeting with the Governor. So he has requested that he will join later on, or meanwhile he can come and join us. So I again welcome all the participants, faculty members, and our expert Professor Venkatapati Prithviraj, and he will be delivering 2 types of discussion, or we can say the 2 topics he is going to cover. First one is on the contest aware system, and then software defined radio. So I think for the communication people, these are the 2 new fields in which they can choose their research area or further knowledge to continue and for the development. So thank you everyone for joining, and I will hand over the mic to our experts. And meanwhile, I will put the slides so that we can continue the presentation. Thank you everyone.
Thank you, Professor Sharma, for that wonderful introduction. And welcome to all of you. A very good morning. I hope I'm audible at that end to the to the audience. I hope I'm audible there, Professor Sharma.
Yes, yes.
Yes, fine. I can put it in slide mode.
So I would just, I would like to confirm from the participants whether it is visible or not.
Yes, yes, please.
Hello, good morning, sir.
Yes, I think we have got the first slide on. Am I audible to the audience there?
Yes, sir.
Yes. A very good morning, ladies and gentlemen, professors, research scholars, students, and all the participants on this Zoom network. This is Professor Dr. Prithviraj, retired principal from Government College, Pondicherry. And afterwards, I had taken an assignment for about 4 to 5 years at this place, namely Rajalakshmi Institute of Technology, where I had prepared this particular presentation. So that's why you see my title there. Of course, then now I've come back to Pondicherry, and I was wanting to give a series of lectures on this particular topic, context-aware location-based services for next-generation wireless networks, basically because of a motivation which I got to get into this area when I had visited Paris in France sometime in 2005 and 6. I had visited the Louvre Museum, and that was a time when I found one of the tourists really struggling to go and look at a particular artifact of his interest or a particular painting of his interest, because that was about 3 to 4, 5 floors. And that is the time when I found there has been a very big requirement for one to really locate depending on the context in which he's looking for. So on that particular note, I would now like to unfurl my presentation. And we'll go to the first slide, please. Yes, this would be the plan of my presentation. We'd start with motivation, and very important would be the importance of indoor positioning and a couple of the basic requirements. We have to define what exactly is context and the context definition, various types, then what are the various indoor positioning techniques which we have, and we harp upon the RF positioning techniques and wireless networks, because a lot of us are working in this wireless domain now with the advent of 5G coming in a big way. I would also dwell on that a little bit and tell you what is the importance of context in the 5G perspective. Of course, we are looking at ultra wideband, which is one of the systems which has emerged. And tomorrow in my presentation, I would look at a very new application of ultra wideband, especially for a lot of our young students and as well as faculty. Today, we find how well we could exploit ultra wideband for car parking applications. So tomorrow I would be discussing that in the series of my second lecture. And then, of course, the architecture of context-aware system. Yeah, we go to the next slide. So then it would talk about position estimation methods, the range-based position location systems, and what are the various steps which are involved in indoor localization. And we talk about 3 very important techniques here on this particular location system. First would be the TOA, time of arrival system, which is basically going to look into, there are 2 aspects to it, 2D presentation and 3D presentation. The diagrammatic representation, simulated results for each one of them, what would normally follow this type of nomenclature, where the true, measured, and estimated values. Then we have received signal strength indicator versus TOA. Next slide. Next. Go to the next one. Next. Yeah. Under TOA based positioning in 3 dimension, we have the direct method, the objective method, and the simulated results. And then we look into time difference of arrival based positioning, the positioning technique, which would generally be looking at general hyperbolic method, the FANG method, and we introduce the Kalman filter, which is going to be really very useful in this entire analysis. Next slide, please. And of course, immediately we look at the simulated results, and then we look at the TOA versus TDOA from general hyperbolic requirement, and then using the FANG algorithm, how the comparison is being done based on true, measured, and estimated user position for this. And then we go to the TDOA-based positioning system using generalized cross-correlation methods. And that is where we would introduce the UWB signal and its reference and see how the improvements are being brought into this overall technique. And it would look at, from the architecture point of view, the signal strength received at receivers 1, 2, and 3 with different delays. Next slide, please. Next. Yeah. Now comes, this is the very important point. Why do we want to, no, go to the previous slide, please. Previous slide. Yeah. Motivation. What is the general motivation for us to get into context-aware system? The most important motivation, the first point is to locate a particular place, person, or object in a very unfamiliar or complex environment. Let me give you an example. You're entering into an exhibition hall complex. You're entering into a campus complex. You're entering into a hospital complex. So you find here then is a big requirement that one has to, especially in a very unfamiliar environment, and if the environment is a complex environment, it becomes much more a very user requirement, which would really help the particular place and the person. Then we have the second example, motivation is the need for navigating. We are in need of a navigation aiding device that would guide the user in this very important perspective, which we call real time. Okay, a real time guiding mechanism is what this would enable. And the third point is today, this is something which especially the handicapped people, or we would like to say the differentially able people and the visually impaired people, they are requiring their guidance to go through a safe path, especially within an environment. Next slide. Yeah, so now we are slowly trying to converge on the importance of indoor positioning and for different application. So here are some of the important aspects which have been highlighted here. So it's not sufficient that we sort of utilize the system, but it has to provide very accurate and efficient positioning services for residential homes, where tracking children, the elderly persons or individual with special needs, such as navigating the blind. And then the second point is locating specific items in stores and warehouses, and locating in the demand equipment in hospitals. Like you have a patient who has landed in a hospital, its immediate requirement is these days the provision of an oxygen cylinder. So that is the time when people start searching where exactly is this. But if you have a context-aware system which can identify the cylinders immediately to the requirement of the technicians and the doctor, we could rush it to the patient's requirement. And then, of course, we have this big requirement to keep track of the patients, not only the patients, it's also the track of the doctors and nurses within a hospital. So you find a multivarious application where this can really be useful. Then we look at public safety applications are needed to track inmates within prisons, navigate policemen, and of course, this big application which we want our young students to look at, firefighters through buildings and houses. You find the firefighting equipment trying to reach the 3rd floor or a 4th floor, and then from there trying to do rescue operations. But then if we are able to use this context-aware systems, we can quickly be able to spot just by a caller ID, which the child is sleeping in a particular place on the 4th floor, to rescue him. Or today, a lot of Europeans have pets who have to be rescued in a firefighting operation. So we find that to be very useful. Then, as my introductory speech which I gave, especially in museums, the Louvre Museum is a very famous museum in Paris, visited by a number of tourists, and museum and exhibitions guide the visitors through the exhibition halls and provide them explanations based on their locations. Lastly, public libraries guide the readers. Today, especially, this will be a very useful exercise for our college students where they want to zoom in on a particular book. Let's say we are looking at electronic communication with a book by Terman, very famous book which we had used those days. So, is a very important person in this, and one can use it for this application. We go to the next one, please. Next slide. Next slide, please. Yes. So in enterprises, we find employees, services, resources on a location-aware basis. Next one. Next. Previous slide, please. Previous slide. Previous slide. Can you go to the previous slide? Yeah. Previous slide. Go to the previous slide. Okay, anyway. Yeah. So in public safety, yeah. So, no. You've gone back too much.
Yes,
Move
sir.
forward,
Just see, confirm, sir, confirm. This one.
Next one. Next slide. Yeah, this is the one. This is the very important slide. Yeah, no, go back to the previous one, please. Yeah. Now, in universities like yours, to keep track of visitors and guide them to their destinations, and especially at PG center, PG classes, keep track of teaching assistants so that students can find them easily. On the military front, soldiers in urban warfare can use it, but this is the most important application which I want to get the attention of all viewers. In emergency services, which include gas explosions, aircraft crashes, earthquakes, tsunami, and train accidents, there is a major requirement to identify the presence of human beings after the accident, human beings within the disaster zone, and also to provide accurate positioning and personal identification for possible human beings who are lying below the debris. That means there is an overlay above the humans. The human beings are buried below the debris. So using this context-aware system, can we quickly locate these human beings who are affected through this accident and take them to the hospital as quickly as possible to save their lives? This, I feel, is one of the, I would say, a sort of a killer application which is now coming up using context-aware systems, which we want our young minds to look at the possibility of getting into areas like this, which has wonderful applications for the country, along with the newer techniques which have been developed, especially with faster services being provided by 4G, 5G wireless communication services. The whole thing can be integrated together to look at some wonderful applications. Next slide, please. Yeah. Now we come to defining what exactly is context, because context means different things to different people. Now, generally, context refers to what surrounds the center of interest, and it provides additional sources of information, especially typifying where of it, who, and what, and increases the general understanding. So by context, increased conversational bandwidth, humans interaction, improving computers' access to context, and increasingly important in the fields of handheld and ubiquitous computing, where the user's context is changing rapidly. Next slide, please. Next slide, please. Yes. Now we try to define the who of it, what of it, where of it, when, and why. The who pertains to the social context. Very important. This consists of information which as user identification and identification of people near the user. That is generally typified by the who of it. What would refer to the functional context, and this consists of information about what task the user is performing. Where of it is the location context, which has very great significance in the present context. This consists of information about where the system is currently located. This is most widely used type of context for developing context-aware application. So especially I was telling you, in a disaster-prone zone, if you are able to zoom in and then locate particular persons in this particular area, it would be a lot of help to rush him for rescue operations and for medical attention. Then we come to a temporal context, which is typified with the when of it. This specifies the time of the day, the date, and month. Okay, that is basically being referred as when of it. And then lastly, we come to why, motivating context. This specifies why the user is performing a certain task. Okay, and we conclude that whole thing in this context as emotional and environmental context. So this includes information such as the user's emotional states and information about the environment, such as the room temperature and the illumination level, where he is located. Next slide. Go to the next slide, please. Yeah. So this is again a little bit of definition which we have given so that everybody will have an idea from where we have sourced all this, and especially from an engineering perspective, which is important for us. According to Schillit and Thamer, it's basically trying to tell the location of use, the collection of nearby people and objects, as well as the changes to those objects over time. Okay, so in this context, we go back to one of our former Indians who did this wonderful work at Georgia Institute of Technology, this Professor Ashin Day, and his definition of context. You will see his earlier papers are all referred to Day and Brown, and I will take Day's definition here, Professor Day's definition. He says, context is any information that can be used to characterize the situation of an entity. Now, what is an entity? An entity is a person or object that is considered relevant to the interaction of the user and an application, including the user and the application themselves. I'll repeat because this is very important for us to understand. Context is any information that can be used to characterize the situation of an entity. Now, this entity could be a person or object that is considered relevant to the interaction of the user. Okay, and an application including the user and the application themselves. So that sort of clears us about the context and the frame in which it is being referred and its definition. Next slide. So now, with that background, we now look at various positioning techniques and technologies. Of course, as engineers, we would like to compare them. And because before we sort of pick up one of these positioning techniques to sort of take up our application, so it is a must that, so these are things with which we are already familiar with. So with that background, we now go to a comparison of these technologies for various aspects. Infrared is something which all of you have been using in your TV receivers, okay? RFID, Bluetooth, Wi-Fi, all that with your mobile. All of you are very maybe ultra wideband is not penetrated to that extent, but the modern radars, especially on the vehicles, are all coming in a big way with these applications. Next slide, please. Yeah. So these are the various positioning techniques. A little bit about some of the drawbacks which is talked about. Okay, we go to the next slide. Let's go to the next slide. And on the RF positioning technique, the big requirement is for the product designer and developer have specific characteristics to optimize certain conditions while creating this with wireless technologies. And this approach has led to concepts like the wireless area networks of different magnitude. And each type of wireless area network signifies a specific combination of radio characteristics, in turn translate into specific application and usage. Okay. Next slide, please. Okay, now before I go on to use this, of course, I've taken this reference from IIT Kharagpur, where we have a very strong group on wireless networks. But before I go to sort of further explain the adoption of a particular wireless technique for us to do the context-aware system functionality, what is very important in this is today we are looking at several parameters which are going to exist for us, and then we have to look at in 2D set of parameters, in 3D parameters, and then after we locate the particular person or the context in which we have explained now where it is very important is how do we use a technique to navigate in an indoor system, and then finally to accurately position this for various operations. So here on the wireless techniques, we have, these are different technologies which have been used on the personal area networks, the local area networks, the MAN networks, the wide area network. We go to the next slide. So now we have a comparison, because this is very important from an engineering perspective. On the wireless PAN personal area networks, you will find the Bluetooth being exploited for that, but the range is of the order of 10 meters. The power drain is pretty low, and the speed is typically around 800 kilobits per second. And we find its elegance, the Bluetooth elegance is to do the cable replacement, especially for nearby devices, and enable us to have a sort of a tetherless communication, which is possible. Then we come to the wireless LANs, which typically exemplifies a 10-fold increase in the range to an access point, and the power drain is medium. And you could see the escalation in the speed, the transmit speed, which translates from 800 kilobits to about 11 megabits. We are typically talking about IEEE 802.11b. That was the first one which came out. And for young students, what is very significant about 11 Mbps, if somebody keeps asking you, especially from the Ethernet point of view, one of the greatest sort of attributes we give to IEEE 802.11b is that our standard speeds on the Ethernet cable was typically of their order of 10 Mbps. So here came the wireless one, 802.11b, with a speed of 11 Mbps. It was able to beat the wired one by 1 megabits. That was a big happening at that point in time. Of course, before we translate it to the other ones, we will look at 811G, Y, F, so many other things which have come in. Okay. Now, wireless wide area network on the WAN, it translates to 2 to 3 kilometers, and you will find the data rates of the order of about 56 kbps, typically being exploited by our 2G global system for mobile communication, GSM, okay, CDMA, GPRS, CDPD, voice and data communications. What is very important to youngsters, young students to remember is GSM was basically a voice-centric network, but then please remember, thanks to today the great, what is it that we ask our young students? If you ask them, what is the killer application which has sustained 2G wireless networks like GSM? Why is it that people are not disposing it off still, even though the data rates have been pretty low? Okay, one of the big killer applications, especially today, we find either the fishermen of Kerala coast are using, or the vegetable vendor is using, or the politicians today are using, especially for their canvassing today, using the killer application for them is SMS. SMS, okay, is the killer application, even though it is at a modest rates of 9.6 to 14.4 kilobits. It started, they are still able to use it, and it is able to see a lot of good applications which are still being done. Okay. Then from there, we translate to wireless metropolitan area network, which goes to 30 kilometers, very high, and the data rates translate to 1.5 megabits. And this has basically been able to replace the ISD and DSL and all that. And lastly, the global wireless area network, which goes from 500 to 1500 kilometers, where all our satellite application, especially the nano satellites and the CubeSats, are all being positioned. And especially they would like to look at an orbit typically between 500 and 1500 kilometers. At this point of time, I should also bring to the knowledge of our students. People might ask, why don't we have this satellite in this orbit from 2000 to 9000 kilometers? Why is it that we don't find satellites being located in that orbit? Okay, so you will find this is sort of a forbidden region, especially we try to avoid right from say 1800, 1900 to about 9000 kilometers, basically because of a region, please note down, is a region called the Inner Van Allen Belt region. The Inner Van Allen Belt region, because this is basically the trapped high energy particles. If the satellite enters that, you will find it will get burnt up, the complete electronic cable. That's why we restrict it to this. This is a passing thought which I thought I would share with you. Next slide, please. Yes, now we come to one of the greatest sort of utilization, which the ultra wideband capability, which we will be using it for different applications. And in the process also, we get a chance to compare WLAN, Bluetooth, WPAN, UWB, and ZigBee. And we will be telling you various reasons as to, I'll be telling you various reasons as to why UWB is going to be exploited in a big way. So if you look at that, 802.11a was basically operating in 5.4 gigahertz. 11b is the unlicensed band, 2.4 gigahertz, where that is where you will see most of them, the WPAN applications. And you will find here, when we come to UWB, which is classified as 802.15.3a, you will find very important the presence of that wide excursion in frequency from 3.1 to 10.6 gigahertz. It's almost covering our microwave band. Those of you are familiar, from 1 to 12 gigahertz is where normally we talk about our microwave band. And we would look at that aspect. And then we find the important thing is the data rate for this particular UWB is maximum data rate. You will find which was a very modest one in the earlier ones, it gets to data rates greater than 100 megabits for different applications, especially UWB, not only having larger bandwidth, but larger data rates, and the range, which UWB is restricted to 10 meters, can be improved to 100 meters if required for different applications. Go to the next slide, please. Next slide, please. Please go to the next slide. Yeah. So now one of the first things with which we have done the sort of context-aware system is a short-range communication technology using Bluetooth. And this is basically, you could see the sort of restriction it had, but it has got a lot of good elegance and good acceptance, and it is also able to handle both data and voice simultaneously. Next slide. Go to the next slide, please. Yeah. So on the Bluetooth basics, we have the ISM band is from 2.42 to 2.4825, and it's basically quite a reliable system because of its usage of spread spectrum, frequency hopping. So you find the security to be quite good in that. And you could see the various classifications of this and the data rate for which this particular thing is being used. Next, go to the next one. So we summarize the big benefits of Bluetooth technology. It's a globally available one, a range of devices, globally accepted specification, and fairly secure connections. Next. So now we come to Wi-Fi and the WLAN products, and it emphasizes low power, short range, and higher energy intakes to offer a 100-meter range with a data rate of 11 megabits, and provides the new wireless coverage for an already existed cable network. And of course, we need that cable connection at the access.
जगावा उसका नीचे खत्म हो गया था ना, सुनो ना, उसका जगावा खत्म हो गया था ना नीचे.
Office and industrial workers, students will use Wi-Fi for network access. Next slide. Next slide, please. So now we tend to compare Bluetooth and Wi-Fi, and you could find how this whole thing takes up, and you find one is, of course, the range, then the data rate, and the power consumption, and the primary uses, the usage location, and the developed start date. And you could see the specification authority, which are there. And the devices with which we can use this are basically the mobile phones, your PDAs, and whereas here the notebook computers, desktop, and the computers with which we can use this. Next. Next slide, please. Okay, now we come to ultra wideband. This is the system with which we have been harping to venture forward and see a lot of benefits which can accrue from it. So what does it do? This system transmits signals across a much wider frequency than conventional systems. And you would find, because of the narrow pulses, we'll be seeing more details about ultra-wideband in tomorrow's lecture. It's a very practical application. As I was telling you that we want to use it for a car parking application. That, I say, would be a good killer application for UWB. And the bandwidth of UWB signal is at least 25% of the central frequency. And most common techniques for generating a UWB signal is to transmit the pulses with duration less than 1 nanosecond. So what are the great advantages of UWB we find? So it has this ability to coexist with current narrowband and wide radio services. It has large channel capacity. And this is a great attribute to it, where we say it has the ability to work with low SNRs, low signal to noise ratios, low transmit power, resistance to jamming, high performance in multi-path channels, and simple transceiver architecture. So I go back to that previous term which we are saying, resistance to jamming, high performance in multi-path channels. Because today we have a lot of people who want to eavesdrop. So you find UWB to be a very secured system, which would prevent that. But on the multi-path channels, we find all the other RF techniques suffer from a lot of this multi-path signals. Whereas when we use UWB, it is able to segregate very well between the direct path and the multi-path. So that straight away we can use a good filtering technique to remove that, and we can only capture the direct path signals. That's where UWB scores over the other RF techniques in a big way. Next slide, please. Yeah, so accruing the other major benefits, we find high bandwidth, can support real high time definition video streaming. See, slowly the newer applications you can embrace and bring it to, and offers high performance, especially in noisy environments because of a pulse type of signals, and high degree of security with low probability of detection and intercept, and very reliable in hostile environments like a metallic environment or a factory environment or things like that, and delivers higher signal strength in adverse conditions, and enables ultra low power, smaller form factor, and better mean time between failures, all at a reduced cost. Next slide, please. Okay, so based on this, what I did, and based on that particular, my introductory speech I gave you, wherein I thought about this wonderful application when I visited the Louvre Museum. We took up this project with my BTech students. Can you imagine? Just the BTech students were able to do this. And it got immediately accepted in an IEEE conference as early as 2005. So that was the paper. Incidentally, Professor Sharma, I will be sending that paper, which has been published in 2 journals across for the benefit of the students. But this presentation of these slides, I'll be doing it tomorrow. And the title of that presentation would be Real-Time Guidance for Indoor Navigation Using Bluetooth Technology. So what I had done as Director IT at Government of Puducherry, they gave me an assignment. The local museum in Pondicherry, can we use your technique for indoor navigation? That's why we ventured into this project. And we were able to implement this. And tomorrow I'll be showing the slides as well as those papers I'll be forwarding today itself. And my request to the students to kindly go through those papers so that you will be ready to appreciate tomorrow's presentation. So in the above proposed work, we have exploited the Bluetooth, and it tells you very clearly how to navigate within a museum, how beautifully this technique can be used, the context-aware system. So what is very important is we have studied the various techniques, but how is it in a very simple way in 2-dimensional case is where I'm going to show you how for indoor navigation using Bluetooth technology, we are able to do real-time guidance. Then that is the proof of the pudding, that once we have gone through all this type of inputs which I gave you in the previous slides, we then take it onto a good application, a good engineering application, which all of us as engineers can appreciate. So the proposed work, we have considered a linear system model, and Kalman filter assumed a Gaussian noise model. Of course, I'll be talking in Kalman filter in a big way. One of the very important points to remember for all of us is when you're in an indoor environment, please remember it is a very, very noisy environment. So normally for two-dimensional navigation, we would need 3 access points. So we would like to use 3 access points and get the signals, and our normal thinking would be these 3 access points would all integrate at one central point. Need not be, as I'll be showing you tomorrow and also in the present lecture, that they are not necessarily located at a single point, okay? Even though I've taken that as a simple case for RSSI, but you will find that instead they are over a particular region. Okay. So then what we do to take the generic case, this is a linear system which we start from there. We then use this technique to navigate and take it with my master's students, MTech students, and then finally there was a PhD student who then took up this. And the work which I'm presenting subsequently are all the work presented by my research students, and all those publications have also been made. So I will be sharing those publications also with you. So in the above proposed work, we have considered the linear system model. Here, what we do is improve the system performance, eliminate the linearity assumption, and instead describe the system dynamics by a more complex set of nonlinear equation. And then we ultimately go to multi-dimensional scaling to locate mobile station for position estimation. Next slide, please. Okay, now we'll slowly bring in the diagrams, and this is the general architecture of a context-aware system, and the context gathering, it would start from that, then it would proceed to context-based generation, and then we look at the context-aware application. So these would be basically the takeoff blocks from where we would get into the complex systems. Next. Next slide, please. Yeah. So in the proposed model, here we have taken the ultra-wideband positioning system. It's a very simple positioning system which we can establish in our college itself, in our wherever this type of a system, and it just basically you have 3 access points, UWB access point, 3 of them, and then we have the UWB device, which normally manifests itself in our mobile, which we carry. And then, of course, we have a server through which this whole thing, this is a simple model. Go to the next one. So now we look at the position estimation methods and how it can be achieved. First one, we use the direction-based position location system, which is based on direction of arrival, the angle of arrival. And then second one is the range-based position location system. So we will be taking each one of these applications separately and then look at the simulation which has come out, the results which have come for that, and how we are able to sort of summarize the results subsequently and draw the inferences from. Next one. Next slide, please. Yeah. So this is the first system, received signal strength indicator, RSSI, which is the oldest system which was available. Of course, it is sort of pregnant with a lot of problems, which you would see. And you would see that it has been used to measure the received RF energy. And it has some limitation. One of the biggest limitation is the signal strength decreases with distance. So tomorrow's presentation, the first one, especially on the real-time navigation, will be using the RSSI, because we use that technique to learn about it and then translate to the TOA and TDOA techniques. Okay. So then second one will be the time of arrival. It is the computation of the time taken by the signal transmitted from the source to reach the destination, because there's a clock which is required there. Then we come to time difference of arrival, which is one of the most elegant techniques, which dispenses off with the clock which was there in the TOA system, and it defines a beautiful hyperbolic locus on which the target lies. Next slide. Yeah. So this is further elucidation of what are the range-based techniques, how is the RSSI things basically coming about, and you could see what I was mentioning earlier, as you will see in one of the slides, where that intersection we think is going to be at a central point, which is coming from the 3 access points. And then we look at time of arrival technique and time difference of arrival technique. Next one. So now we once again go back, because at the end of the day, we want to find out what would be a simple flow chart mechanism by which we can get the steps involved in indoor localization, and how we can use that to go about trying to do this prediction of the position and to how to take it forward. And we keep it very generic so that it can be applicable for any of the estimation techniques, whether it is using RSSI, which you would see tomorrow in the presentation, TOA and TDOA, which you would be seeing today and tomorrow in the presentations which are being done, and the position estimation. As I was telling you, the very essence of this entire context-aware technique is first to deal with the parameters, okay? Then we try to look at how to go about the translation, the estimation, and then the translation from that particular point, and then to pinpoint where exactly you're located in a very accurate way is where all these things would summarize and then try to take you forward. So then we are also, please remember, this is very important for all of you to understand that the indoor system is a very, very noisy type of system. And for us, when we have to have our electrical signals operating in that noisy environment, we have to find a very elegant way of overcoming the background noise. And that is where we exploit the Kalman filtering technique, which is going to get elucidated in the future slides, which I'm going to show you now in a big way. Next slide, please. Yeah. Okay. Now this is going to talk about TOA, but we would, Professor Sharma, do we have to take a small break in between for about 5 to 10 minutes for the students to take a break, or we can continue?
No, sir, you can take.
We can continue now.
If you need. Yeah. Break
Okay.
From our side, no problem.
Okay. I will take a break after another 10-15 minutes, just to have a glass of water and come back. Not a problem. Okay.
Okay. No problem. No problem. No problem.
Okay. So this is TOA based positioning technique, and the range measurements from the arrival times, how it is being done, calculated, and all that. Of course, all these things we have also put together on the research papers, so which I will be providing with Professor Sharma, so the students and faculty can go through that and to look at the different presentations, and which would sort of reinforce the points which are being put forth. And this is how the distance calculation is being done. Next slide, please. Next slide. Yeah. Now, I want all your attention to this very important slide, which is the triangulation This is basically the triangulation technique which we use. Okay, the diagrammatic representation. ABC represents the access points, especially, please remember, you would need 3 access points to do 2D type of triangulation concept, and within 2D to locate the particular object or the artifact of interest or whatever type of thing which you want. So as you can look at here, we have shown the condition where all the 3 circles which are emanating from the 3 access points, they are intersecting at one central point, which in a generic sense is not there. It will not be. Okay, this is a particular situation which we cannot always, we have used that in our first application. Tomorrow's presentation will show you that. Okay, but in a generic application, it is not applicable. It will be over a region like the box region, which I will be showing you in subsequent slides. Okay, so that is the more general definition. And basically, using this concept is how we have gone about trying to do the prediction of where exactly is the customer or the artifact or whatever it is we are looking at. Next slide, please. Yeah, so these are all the results based on which I'll be showing you the graphs for you, the TOA-based positioning system, the true value, measured value, estimated value. Okay, and this is how this whole thing is being done. And now we'll go to the graphs. Next slide. Okay, so you could see this is the first of the graph, which is coming here, true value here. Which is, we go to the next graph. Next one. Yeah, this is the measured value, then the estimated value, and then now we'll find them superimposed on each other. Next one. Yeah. So now you could see how the comparison is being done, the true value, measured value, estimated value, using these techniques, and how depending on different techniques, we are able to, and then depending on the situation, how is it, and we get further results to corroborate this particular graph. Next one. So on the simulated results, you could see measured, estimated, true, and how the differential things coming up. Next. Yeah. So here then the RSSI versus TOA, you will get that better comparison done in the papers. So how these things compare, and you could see how the TOA's technique is a much more accurate thing than the RSSI. It is to enable that comparison from an engineering perspective, so that, because ultimately our requirement is to exactly identify the system accurately. Next one. Next slide, please. Yeah. So now we then use this system, right? Where now, because we have to now translate from a 2D system to a 3D system. So that is why immediately you find we take access to 4 reference points. Reference point 1, 2, 3, 4. Okay. And the receive signal, the location metrics, the position algorithm, the location estimate, and the display system. So this is how we can configure a complete system which can be easily positioned for us in a beautiful university like you, where such a system can be beautifully exploited and system made very useful for everybody. Next slide, please. Next slide. Yeah. So here now, as I said, since we want to go in for from a very coarse method which we are using in RSSI, okay, which had that type of limitation. We then translate that linear method to a direct method here, and this is how that entire direct method, which, what does it do? It gives the exact solution for a set of simultaneous equation for estimating the position in 3D. The system needs 4 access points for accurate positioning. And in the Cartesian system, the range, distance, and all that are identified by these equations, which are put out here in this slide. And what is important is, you remember earlier I had pointed out, when we are using 3 access points, we are looking at that particular situation where all the 3 access points will converge at a single point, right? Not necessarily so, it will be over a region. But moment you go to 4 access points, the system becomes much more aggravated. The system becomes much more aggravated, and you will find zooming in onto that singular point will be much more difficult. So we take help of this wonderful tool which is available for us, basically the Kalman filtering technique, using which we overcome that problem in a big way. Next slide, please. Hello? Professor Sharma?
So from which slide I have to start? Excuse me, sir.
Hello?
Yes, sir. You are audible.
Yeah, yeah, you're audible. No problem. What about me? Am I audible?
Yes.
You can hear
From
me?
which slide I have to start, sir, to display? Yes, sir. You are audible, sir. I can hear you. So
Hello?
from which slide I have to? Yes, sir.
We can go ahead. Okay.
From this slide, sir.
Yeah, you can go ahead. We'll go ahead. We'll stop. Where is that last thing we stopped? I think previous one, huh? Previous slide. TOA presentation. Yeah. So we'll go to TOA based positioning in 3D. Yeah. Go ahead. Can you get the slide? All this you go ahead. All this is over. Next, next, next. Go ahead. Next, next. Yeah, next. Okay, next. Yeah, these are all the mathematics. You go to the next one. Yeah, okay. We'll start from here.
Yes, thank you so much, sir, for your kind support.
Okay, sir.
Oh, thank you so much, sir. That's good.
Okay. Can I have the audience? Yeah, your attention back. So now we are quickly, because we've lost some time, I skipped a few slides. Now we are coming to the objective method. It's normally required for any optimization process. And the ultimate aim of positioning is to obtain an accurate position estimate. And it is nature to define the objective function like this. And this is how all this is being given. Yeah, go to the next slide. Next slide. Okay. Okay. So what we do here, we start the iteration, the initial position coordinates, and the initial transmit time are required. The initial estimated value of the position coordinates chosen to be the mean position of all the 4 access points. Okay. So by utilizing this initial position, because this is very important for us, because we have to start at that initial position. So we'll try to focus on that by taking the mean position of all the 4 access points. And by using this initial position, and the gradient of the objective function position is estimated for the first iteration. And by deriving the objective function, derivating the objective function to 0, we get the value of step size. And the iteration is done for 4 times, since 4 unknown parameters are there. Next slide. Okay, so now we immediately push this onto a flowchart so that it will be very easy for us to follow this entire sequence. We start input from the access points, and then we initialize these values, and we take the mean of the RPs, then we use GK and then proceed, and then we use this do loop condition, get back, and then from this, go to the next one. Yeah, so from this, we are now able to do a comparison because it's very imperative that the moment we bring in all these equations and we get the simulated values, we have to put this onto a result format and then do the comparison. So here what we are doing is, we are doing the comparison between the direct method and the objective method, in contrast to the method which I'll be showing you tomorrow, which is based on the older method for the RSSI. So you could see the 4 access points where they are located on the 4 corners here. And the direct method output, you could see what is it providing us here, okay? And because ultimately we are deriving all this in the 3-dimensional space. So you could see very well the true position, the objective, the object, and the direct method. The objective method and the direct method. So you could see how they compare in this type of iteration. Okay, now we go to the next one. What happened? Yeah, so here what we have done is, yeah, go to the slide position, please. Go to the slide mode. Yeah, fine. So what we have done is we have offset one of the access points from 5 to 4. Okay, the other 3 access points we've retained. So now we do the comparison between the direct method and the objective method with respect to true position. Okay, and the RPs now you could see. So here when we say the direct method and the objective method, okay, so you could see how much the direct methods is getting affected in this process, whereas the objective method is still pretty close to the true position. So you could see how much the objective method brings in about an improvement in trying to do the estimation to the actual level requirements. Okay, next slide, please. Yeah. So with this, we are now able to bring out true estimated and of the random variable position value in terms of time in seconds and the Kalman gain with which the error covariates in all these parameters, which you will get a much greater elucidation when you go through the research papers also on this. So you could see how we are able to do the comparison between true value and the estimated value. Next. Now we try to play with the sampling interval. So we try to see the sensitivity of it. So by varying the sampling interval to see what happens, if it is of the order of 0.1 second, and how is the position value, how is the agreement, the mean error, the MSC values, how it is, and here again Kalman gain and the error covariance. Next slide, please. So here we've lowered it, and now the sampling interval is of the order of 0.01 seconds, and you can see how much is the improvement which has occurred in the MSC as well as in the position value between true and estimated, how well the things compare with each other. Next. So the mean square error on the basis of sampling interval are very clearly given out, and you could see when you start with 1, the percentage is about 8%, on 0.1 it is 6, and goes to 3, on 0.01 it reduces to 4.8. So iteratively you can still come out with a much more lowering of the mean square error which is used, so that is able to identify the target in a much better way. Next slide. Next slide, please. Yeah. So now we go to TDOA based positioning system. Okay. So here in TDOA, the time difference between two access points is converted into range difference. So it's a very elegant way. How nicely, because the TOA we are confronted with the clock, with trying to take measurements from all the 4 access points. In TDOA, we can dispense off with that, and we use the time difference between the 2 access points converted into range difference. And each range difference equation represents a hyperbola, the nonlinear equation, which you will get much more idea when you see the research paper from which these formulations have been done, and between source and the destination at where we are able to access, and you can see the intersection points. Next slide. Okay, so what we do is, now we have the linearizing equations, the algorithms used. First one will be the generalized hyperbolic method, which is used. Then we take recourse to Fang algorithm. So this is an algorithm which brought in a much better result in our estimation of this entire process. So the generalized hyperbolic method, what we do is, here we rearrange and simplify. That means we convert the nonlinear hyperbolic equations to a linear hyperbolic equation, and in step 2, solve, obtain the x and y coordinates of the target. Okay, so this is how we take up. Whereas in the Fang algorithm, we make use of 3 reference nodes, and these are the way they have been highlighted, and we solve the equations to get x from these 2. And then use a Taylor series method to simplify. Next. Next. Next slide, please. Yeah. So now, this is very important. Now we bring in Kalman filter. The magnificent thing about Kalman filter is that we use 2 types of Kalman filter, the unconstrained Kalman filter and the improved Kalman filter, which is called the constrained Kalman filter. So the magnificent thing about the Kalman filter is we have gone through a journey. We have, when we went to a particular point, we went through quite a long journey where a lot of data has been accumulated. The magnificent thing about the Kalman filter technique is it only looks at the previous reading. and then iteratively goes to the next level. It takes that value, on that it does the iteration and translates to the next value. So all the previous set of results which we have taken on that journey can be easily dispensed of with. All that need not be stored in the memory. It need to take only the previous value from which the assignment. So this is how the prediction takes place: state estimate, and the estimate using covariance, and then the update, and which the whole thing, and we get the Kalman gain, state estimate update, the covariance update. So this is a very, very elegant technique, especially in an indoor environment. And we find using this Kalman filter has helped us to do the complete real-time translation from one particular point to wherever we want to do, almost in real time, thanks to the present day sort of processes. The estimation is done so fast, we are able to get this. So using this Kalman filter equation, we are now going to see some very interesting results which have emanated from this. Next slide, please. So this is once again a diagrammatic representation, state space technique representation, basic state equation. This is how it is represented. You could see with this input how this whole thing is done. Okay, and this is how from the output how it is taken back here, and with this the whole thing is being able to put across. Next one. Yeah. So now the process noise WR is added, and then the equation is brought in here, and the output equation is represented in this form. So using these three equations, we are now able to tell through the new iteration where exactly is the target, which is now got translated almost in real time. Go to the next slide. Go to the next slide, please. Yeah, the estimate represented as XRR is calculated based on this, and this is the overall representation through which this estimate has been calculated. Next slide. Okay, so based on this, now we are able to see the simulated results on Kalman filter between X coordinates and Y coordinates on input output. Okay, and this you could see here on the output positions. This is at the input position, and you could see at the output position what it is based on the previous iteration. So how accurately it is able to take in, it doesn't look at any of the previous results. It is only looking at the immediate earlier result from which this prediction has been made. Next slide, please. Okay, and then based on this, we are now using true value, measured value, estimated value. Okay, so this is something which we have done for our earlier results, and you could see how well that agreement is, to what extent, and we are able to do the prediction so accurately, almost in real time, thanks to the present day processor technology which is available within the system. Next one. And here we are now able to do the comparison between TOA versus TDOA. Please remember, we can couple the TOA technique with Kalman filtering, TDOA with Kalman filtering, RSSI. So when we do this comparison, you could see how much improved is the result which we have got, because ultimately we want to use the best of them for us to identify the system. And we find TDOA taking the supreme lead in this context. Next. Okay, so now we come to the earlier technique which we have used. We now use the FANG algorithm, which is an improved, which is able to produce a much more accurate result compared to the earlier one technique which we have seen. So we look at now TDOA, the comparison of TOA and TDOA using the FANG algorithm, and we find the FANG algorithm has been able to produce a much more accurate result compared to the normal TDOA, which we did in the previous comparison. That is why the improvement using FANG has been brought out in a very clear way, and you could see from the results which are emanating how much is the improvement coming through. Next one. So now we turn to a new technique called TDOA estimation by generalized cross correlation. Okay, it's a new technique which we use. That means we cross correlate pre-filtered versions of the received signals at two receiving stations. These signals are integrated and squared. This is performed for a range of time shifts until a peak correlation is obtained. The time delay causing the cross correlation peak is an estimate of TDOA having the value T. So using that technique is how this has been formulated. More about this in tomorrow's presentation, which we will be doing. Especially we are using this technique in a very accurate way to do an estimation for car parking using the UWB technique. So we'll be exploiting this technique tomorrow and showing you how accurate this result is and to what extent we are able to pinpoint the accuracy to try and do and get onto a very practical application using this technique. Next slide, please. Okay. Previous slide, please. Get to the previous slide. Previous slide. Yeah. No, previous one. Previous to this. I'm going the other way. Previous. Next. Earlier. Earlier signal. Okay. So, yeah, this is the one. Yeah. Now go to the next one. Yeah, correct. UWB reference signal. So you have UWB and the reference signal. Okay. So we are now using this technique. Okay. So now that we are going to get it from the access point. Next slide. Go to the next slide, please. Yeah. So received UWB signals at receiver 1, 2, and 3 with different delay values. Okay. So then what we do, we use the correlation, integration, and squaring of the reference signal to signal of receiver 1. And then we try to do the comparison. So this is correlation, integration, and squaring of reference signal with the signal at receiver 2. Similarly, next, receiver 3. Go to the next one. Yeah, this is for receiver 3. So now that we have got all three of them, now you see, go to the next one. So then intersection of the hyperbolas without noise is where we are able to locate. Next, with noise, we could see how that comparison takes place. Next, so the mean square error is the square, yeah, mean square error is the error which we have got. Now we have done it with Wi-Fi signal generated with a frequency of 2.4 gigahertz. So we are doing it for UWB different signals and then doing the comparison. Next, go to the next one. Yeah, now we can see with Wi-Fi how is the comparison. Okay. Next. Go to the next. Go to the next one, please. Yeah, now we are going to noise. That earlier was without noise, with noise. Similarly, we have done for UWB without noise, with noise. So then we have the comparison of all this. Go to the next one. Okay, so we find mean square error. Mean square error, true position, estimated position. And you could see this is how it is coming here. I think we'll get it in a tabular column to see it better. Next. Okay. And then this comes to the hybrid range. You see what happens, okay, based indoor wireless localization, that basically an unconstrained nonlinear optimization for UWB application. Okay, so we find sometimes we are in between indoor and outdoor range. So we are looking at what should be a technique to basically use to come out with, when you use this hybrid technique, how it can be done. And this is how the block diagram comes out to enable that type of a hybrid technique processing. Next. Yeah. Now, this is what I was telling you about. Okay. Whenever we have these 3 access points and we are now trying to locate the user who's located within that premises or the target or the artifact, you will find earlier the central point was getting intersected at a single point on the 3 circles. But what is more generic is to see it over a region of interest. There will be a region of interest. Okay, so from there you have to zoom in to your accurate location. So this is in 2 dimension. When you go to 3 dimension, it becomes much more complex. So unless we have this type of excellent Kalman filter sort of technique by which we can go to that particular thing. So this is the TOA based location measurement circles, overlap region in which the mobile subscriber, the MS, lies. Next one. Next slide. So selected indoor path models. So we have median path loss. This is how the calculation. Selected indoor path loss models which are used both line of sight and non-line of sight type of a thing. And here we go to the results. We take care of all these parameters. Log normal, shadow fading, standard deviation, all that is being reckoned here, with which we are then trying to do the prediction. Next, go to the next slide. Yeah, this is the median path loss which you have on LOS and non-line of sight signals. These are standard equations which everybody is very familiar with. Next slide, please. Yeah, so based on that, to mitigate the shadowing effect by data smoothing, the receipt path loss at ith base station, RLOS and R non-LOS are the estimated propagation distances. No, go back to the previous slide. Under LOS non-environment, and could be written specifically in this form here. So based on that, the transmit receive separation, you could see the decision boundary which is there, estimated mean path loss on the LOS model, estimated mean path loss, the non, and you could find the LOS and N-loss decision boundary as to where it is getting situated. Yeah. Okay, so it is able to smooth this out and come out with a very, very effective way of handling this. Next. Next slide, please. Okay, next we go to TOA range measurement and to discriminate loss and N-loss condition in a similar way, and then we do the estimation. The result of this testing, weight factors are assigned for the following rules, and based on that, now we'll see the result. Next. So we find the weight factor for the 3 base stations describes the credibility of TOA range measurements. Algorithm can be summarized as nonlinear unconstrained optimization approach, and it is represented as the argument of fx. To solve the nonlinear objective function, a MATLAB unconstrained nonlinear minimization function has been adopted. So, which we will see in the next slide. Okay, so generalized cross correlator output. Next slide. Estimated mean path loss invariance of LOS, N-loss, function of TR separation for the three ones, which you can see here. Next. So the PL distance mapping for loss and N-loss identification and calculation of R threshold here. So this is how we are able to infer that and get this value. Next. So weight factor in the location algorithm for loss and N-loss, and you could see all base stations equal weight alpha, and here you can see how this whole thing has been done. Next. So conclusion is the hybrid range based indoor wireless localization. True position mobile subscriber is 6.5. Estimated is, can you see how close it is? 6.078 and 5.09 based on MATLAB simulation. And proposed hybrid TOA RSI location algorithm performs better than other algorithms. The results are due to LOS N-loss identification and the selection of weight factors, which reduces the location error for the proposed algorithm. The N-loss error not only depends on the environment and base station MS deployment, but also on the performance of different location algorithms. So this is little subjective here, okay? So those things you have to put them together before we are able to get that accurate result which is required. Next. Next slide, please. Okay. Right. So now what I would be doing is, I will be sending you the list of publications which have come out from this type of thesis work and what is very relevant, in addition to sending you the first publication which I told you, which is basically the real-time movement within a museum, okay? Real-time travel through that. And then some of these publications, which are very useful for us. Okay, on that note, now I would like to go back to my first slide. Can you go back to my first slide? And I would like to make a few comments before I hand over to the question answer session. Okay. So what is probably you could go to this second, third slide. Yeah. Okay. Can you go to that? Okay, let it be here. Doesn't matter. Yeah, let it be here. So on this first slide, what is very important, just to get the attention of our young students. All of them, our students, what are they very fond of, Professor? They are very fond of Nike shoes. Nike shoes, right? Most of the students like it very much. So let us say they are entering a very big mall. Let us say in Rajasthan, wherever we are, in Bhopal, wherever we are. And this mall is of 4 to 5 floors. So what is it that we can do? These students want to purchase Nike shoes of the order of size 8 or 9, let's say. Now, when the moment they are near this mall, in comes a push information which says we have Nike shoes of order 8 on floor 2, which will cost you so much. But the same shoes on floor 6, here maybe it is costing them say 400 rupees. The same shoe on floor 6 is costing them only 300 rupees. They are giving additional discount. So on this context-aware system, now the students get through a push-pull mechanism onto their mobile, depending on their area of interest, they can get all this information pushed in. Okay, here then is a wonderful tool by which they can get, depending on if these students are, they can probably look at a jacket, they can look at anything else. So today, because second floor is nearest to the mall, people are paying higher. But if they can get this information from floor 6, which is selling it at a much lower price, student can get. So if they can position these things very carefully, you could see how much of advantage do they get. That is one area. So the other big requirement where we thought this context is playing a very big role is, one is entering a very big exhibition, open exhibition space, where you find the mother, father, a teenage daughter, right? They are entering this exhibition. She has a lot of her friends. She wants to travel separately. The mother, father is so worried whether they will have an access to this girl, whether she will get lost in the crowd. Thanks to our context-aware system, by wearing a simple docklet on her on her neck, the parents using on their system with this context-aware system can simply design this, and they can easily locate where exactly she is in a crowd. I'm just giving 2-3 examples like this, okay? But more than anything else, what we want our young minds to really look at, some of the very important applications which I was mentioning earlier, especially in a disaster-prone situation, okay? Today, we have seen either during floods or during train accidents or during anything else. Today, the big emergency is we find a lot of people getting buried beneath the gravel. So is there a good mechanism today using our modern day techniques? Now, we would like them to sort of get into a 5G type of situation. The 5G unfolds itself very well to embrace itself with context-aware system, because that's a very fast system with excellent bandwidth and very fine capability with which we want our young students and research scholars to explore on these newer areas, which I have been just putting out in my plan of presentation. I have not touched that area, Professor. This is open area, very open to them, and we would want students from your university to embark on this great research here. Wish you all the very best. Thank you. Now I'll open it up for question and answers.
Yeah, participants can ask question, sir, or they have any doubt.
And if otherwise also, they can send it by mail, sir. If they are finding it difficult to ask now, they can even send it by mail, which I can, you know my mail ID, you can give it to them, they can send it across, and I will then try to give whatever replies appropriate for that.
The main requirement is the how we can increase the bandwidth of the internet connectivity. Yeah, because everywhere we are facing the problem. And
I understand. You're finding
because of this COVID-19. Yeah, the heavy loaded means our internet connectivity.
Very heavy loaded. I know. We are thankfully at Pondicherry we are saved from the situation. Otherwise, because of our lower population, otherwise we would also be in between. Of course, sometimes we also face this problem. But by and large, anyway, I should really thank you for giving me an opportunity to put this very virgin area, I thought, and which I think our youngsters will have a lot of ideas coming out from this, and they will be able to take on new this. And for the audience, I am very happy to inform you that the entire PPT material I have handed over to Professor Sharma, and I'm sure you will get an opportunity to access that. In addition to it, I will be forwarding the research papers which are associated with this presentation, from which you will get more details. And for tomorrow's presentation, only the first presentation paper I'll be sending. The others I'll be sending you tomorrow, including that very, I would say, one of the killer application which we did using UWB is for a car parking application. So there again, we want your students to embrace that technology and take it much forward, because I'm sure our youngsters have a lot of newer ideas to use this, because it's a current requirement, and Bhopal will greatly benefit from these type of applications. Thank you.
Yes, sir. Thank you very much. And really, it is on the shoulder of the young people to develop some new things, both in case of communication or the internet connectivity, and the topic you have covered.
Yes, sir.
The contest aware system that is really needed. So thank you very much.
100 slides available, sir, so they can leisurely go through. Then tomorrow's presentation, I'll be giving another further of them. And
yeah, I will share the slides with the participants. I will share that. Thank you very much, sir. So tomorrow again we will meet at 11 o'clock.
Okay, thank you. So thank you very much, Professor Sharma, for all the help. Namaste, sir. Namaste. Thank you.
Thank you, sir. Thank you.
So I leave the.
Yeah.